A very good morning to all of you. I cordially welcome you all for this applied thermodynamics course. In the today's classroom discussion topic of the 15, we are going to discuss about the problems on performance of boilers, equivalent evaporation, boiler efficiency, and boiler trial. So the motivation for the today's class is it is very essential to know the performance parameters of a boiler to assess the performance of a boiler. And the outcome of the lecture is I am expecting every one of you in a position to estimate the performance of a boiler. So in the previous class, we discussed about what are the various parameters by which you are able to assess the performance of a boiler, like equivalent evaporation and factor of safety, factor of evaporation and boiler efficiency, superheater efficiency, economizer efficiency, overall plant efficiency. So these are the various parameters which we are able to use to assess the performance of a thermal power plant. So based on the previous class introduction, now in the today's class we are going to solve some problems on the performance of a boiler and similarly on the boiler trial. So in the last class also we solved three problems based on the performance of the thermal power plant. So now let us solve the other problems on this particular the boiler trial. So let us see the first problem. A steam generator evaporates 18,000 kgs per hour of steam at 12.5 bar and a quality of 0.97 dry from feed water at 105 degrees centigrade when coal is fired at 2040 kg per hour. If the higher calorific value of the coal is 27,400 kilojoules per kg, find the heat rate, equivalent evaporation and thermal efficiency. So as usual, first any problem, first you write down the given data. So that is first you go to the steam tables. He has given that it is a 12.5 bar. At 12.5 bar you note down what is the value of the HP, HF and similarly HFG. And at 105 degrees centigrade feed water temperature, HF value also you note down. And then you calculate what is the heat rate of the boiler by using this particular formula, that is the m dot s into h minus hf1. So h minus hf1 already we calculated here, that is a 2284.94. that is h is nothing but because it is a wet steam he has given, so hf plus x into hfg, that is a formula to calculate enthalpy of the wet steam. So it is a formula to calculate the wet steam, and hf value directly we know 440.13. So by substituting all the values, we are able to get heat rate of the boiler is equivalent to so and so. And next one, the second bit is equivalent evaporation. So based on the previous class notes, just you recollect the formula to calculate the equivalent evaporation. The formula is MA into H minus HF by 2257. So MA is equivalent to MS by MF, that is the mass flow rate of the steam by the mass flow rate of the fuel. So it is equivalent to 8.823. And by substituting all these particular the values, the second bit answer we find it out as 8.932 kgs per is the kgs of the fuel. So coming to the last bit, that is the thermal efficiency. That is the, let us find out first of all the boiler efficiency, that is equivalent to heat utilized by heat supplied. So heat utilized, that is already we calculated it as 411.289, and heat supplied by the fuel is equivalent to 558. So substitute here. So we are able to get the boiler efficiency is equivalent to 73.6%. Now let us go to the second problem also. So here also as usual, first you write down the given data. So here the enthalpy of the steam produced, first you calculate because it is a wet steam. So enthalpy of the wet steam is equivalent to HF plus X into HFG. So that is equivalent to 2685. So amount of heat supplied to the steam, because we have to calculate the equivalent evaporation, the formula is MA into H minus HF by 2257, exactly similar to the previous problem. So first you calculate H minus HF. So H will be calculated from this and HF will be calculated from the steam tables. So that is as 62.98 at a given temperature. So the difference of H minus HF will give you 2622.54 kilojoules per kg, and MA value already we find it out. So substitute here, we are able to have 8.38 kgs per kgs of the fuel. And similarly here the boiler efficiency, so heat supplied by the fuel already we calculated, that is the MF into CV. So he has given the mass flow rate of the fuel is equivalent to 275.8 and CV calorific value of the fuel is given as the 30,000. So heat supplied with the fuel, that is in the denominator value, we find it out as 82.5 10 to the power of 5 kgs per hour. So heat utilized by the water during the formation of the steam. So m dot s into h minus hf1. So that is 52.178 into 10 to the power of 5 kilojoules per hour. So by substituting this numerator and denominator values, we are able to find it as the boiler efficiency is equal to 63.24 percentage. So that is the actual evaporation rate. M dot S is equivalent to so and so, M dot A is equivalent to so and so. So that is all these values are calculated from the steam tables. So like this, we are able to solve the problems based upon the performance of the boiler. That is, how can you evaluate the boiler efficiency, and similarly the overall plant efficiency and the boiler trial. How can we conduct the boiler trial? So that is the previous class information is very important one. That is how to evaluate the performance parameters of the boiler efficiency. So based on that, you should be in a position to solve any problem which is given on the performance of the boiler. Thank you very much for listening this particular lecture.